Welcome to the fourth section of the Reactive Microservice Design course. In this section, we will start diving into reactive microservices. We will introduce the means to have a reactive microservice. We'll talk about elasticity and resilience, what they are and why we need it, and we will refactor the Acme bank to be elastic and resilient. So let's introduce the means to have a reactive microservice. In this video, we will run the Monolith application and we'll see why it can scale. Let's start by investigating the code to identify the monolith pattern. As it can be seen, this application is composed by two submodules, DB and monolith, as you can see here and here. Although this is not indication of a monolith per se, it gives you the hint that there is just one location where all the code is stored and run. Looking closer to the project, we can see that the DB project, the only thing it does is to start a local database. It copies the HSQLDB database to your local environment and initializes it with these three databases from this script. The same happens on the monolith, so let's investigate the monolith application. Let's open it, go to its source, Java, and to the start of the application. As you can see, this application is a typical Spring Boot application. It is all auto-wired configured. The application is composed by a couple of services that are separated into separate packages, account and transaction, and these services are used by the controllers. Currently, there are three controllers. The web app controller that bootstraps the application, and the account controller that maps HTTP request to /account, account ID to get accounts from the database, and /account to create new accounts, and the same behavior for the transactions. /transaction, transaction ID will return a given transaction, and when you post to /transaction, you create a new transaction. If we want to better understand the source, we can use the Spring plugin. Here we can look at the account controller, and you can see that from the controller we use the service. And the service implements basic logic. It requires a JDBC template, which is a very simple SQL store interface that is provided by Spring, and we can do simple queries like select everything from accounts where ID is a given ID and transform it to an account object. Do implement the creation of accounts with an insert into the account's ID balance with two values. Looking at the transaction service, it will be exactly the same. The get transaction will make a select statement and execute it on a SQL store, and the create will insert into the transaction table. Although the code appears to be very modular as everything is organized in their own package, with implementation details, API service interface, and the clean usage from the controllers, it's still a monolith, because when you start the application, everything is run on the same process. Also, the database access is shared across the application, which means that there is no isolation of data, forcing the evolution and scaling of the database hard dependency on the existing codebase. So let's see how this application works. We would go to the terminal, we would build it, so it's Maven clean package. This will build the whole project, unpackage it, and it's built. And now we can do docker compose. As you can see, it will start two containers. The first container contains the database, and the second container contains the application itself. The application is started, so we can now interact with the application. Let's open a new terminal and let's interact with it. So let's create an account. An account was all about making HTTP requests, post to account, and we need to look up the controller, and you can see that the account requires an initial balance. So we can say here, let's look, balance is 10. Yes, I need to specify the server, of course. localhost/account balance. And I see that it's created. It's a 202 status, HTTP status, which means created, and there is the account. And we could now interact with the application as we would in real life. Now imagine the scenario that there is a bug on this code. If creating an account would raise an error, the whole application would die because, let's simulate a situation, it would be the same as me killing it. At this moment, the connection is refused. So this means that your application is not resilient. It cannot recover from simple errors. And it's not just questions of bugs. Imagine that there is a network problem between your application and the database, then the whole system is down. And this is not what we want. On a reactive microservice architecture, we want that our application will be resilient. So even if the account creation raises an error, all our end users can still do transactions between their accounts. You should now know that monoliths are single points of failure. In order to overcome the limitations, you will need to introduce more complexity into the deployment, such as load balancers.